What is this? Electric dipole. Suppose these are two charges, one positive and another negative. So the definition is like this. The system of two equal but opposite nature of charges separated by a small distance, this distance, is called an electric dipole. Now the major things are the distance between the two equal and opposite charges is taken as 2L. You may see in your books. Why? Because we locate the central point to be O, and from O we take this distance to be L, this distance to be L. So the total length becomes 2L. So why do we do that? Because anytime, suppose this is a dipole, one plus charge, one minus charge. Anytime, suppose there is a point P over here. So if we ask what is the distance of point P from this dipole, then which point would you select to show the distance? We will select the midpoint O, and we will join this point to this midpoint. So this distance is R. R is the distance of point P from the midpoint of the dipole O. So we take one side to be L, the other side to be L, so that the total length becomes 2L. So that is first idea. Second idea, that if we take an electric dipole, we need to measure it. What is the effect of the dipole, the specification of that dipole? That is dipole moment. So dipole moment is a quantity symbolized by P, and this dipole moment has got certain properties. First is, it is a vector quantity. So being a vector quantity, it should have both, yes, magnitude and direction. So the magnitude is given by definition, P equals to, take the value of any of the two charges, Q, only magnitude, into their distance, 2L. So this is the magnitude. Then comes direction. Direction is taken as from negative charge to positive charge. So minus charge to plus charge. So let us remember, dipole moment has got its direction from negative charge to positive charge. So in this direction, this will be the dipole moment. So anytime if we draw, let it be a capsule like this, it has got two parts. Suppose we give an arrow like this. What does it mean? It means a dipole placed so that negative charge is here and positive charge is here. So this arrow represents a dipole. So this is a dipole. Can you imagine which side the positive charge is? Here, here. Negative charge here. Now another question comes, but before that let us understand its two more properties. Dipole moment. What? Unit. So unit of dipole moment is Q into 2L. Q has a unit, coulomb. 2L, that means length. Length has a unit, meter. So in SI system, we measure dipole with the unit coulomb meter. Dimension, yeah. Dimension of this P vector, dipole moment. Dimension would be simple. I had told you dimension of charge at AT. Remember that earlier I told you. And dimension of length, it is nothing but L. So ATL, Attila, the Hun, no, it's ATL. We will write L, then T, then A. A for ampere, length, time, ampere. So this is the dimension for dipole moment. So we understood what is the dipole moment. In the beginning I told you the definition. Next time you pause the video and try to write that down on your copy, hearing that. So we already learned magnitude of dipole moment. We learned direction of dipole moment, negative to positive. We learned unit of dipole moment, and we learned dimension of dipole moment. Practice one thing. Equilateral triangle. These are distances only. L, L, and L. 3 charges are placed at the 3 vertices. One has 2q positive, one negative q. This is also negative q. 3 charges are placed at the vertices of 3 vertices of an equilateral triangle of each side L. You have to calculate dipole moment of the system of charges. Only magnitude. Pause the video and try to do it by yourself. Then move forward. I'm doing it. Okay. So, the idea is, think this 2q charge to be 1 plus q and 1 plus q. So, what is the difference? This 2q becomes plus q and plus q. So, can you see a capsule? Plus minus, one dipole. Another capsule, plus minus, another dipole. So, there are 2 dipoles. Can you see it? So, the dipole moment for this, minus charge to plus charge. So, minus q plus q. So, the dipole moment would be along this. Let us call it P1. Similarly, dipole moment minus charge to plus charge. It would be again along this. So, dipole moment for this, along this. So, let us call it P2. Think about it. I'm simplifying it. I'm erasing these unnecessary parts. So, can we see 2 dipole moments, P1 and P2, in the figure? We can see. Can we see the angle between them? No, it's not given. It's given indirectly. This angle is how much? 60 degree, equilateral triangle. So, this angle would be how much? 60 degree. Now, we know from this that P1 equals to P2 equals to, how do we know? We can see it from the figure. What is the value of P1 or P2? Q, charge of anyone, Q, into 2L. 2L is here L only. We will consider the length between the 2 charges. It is not necessary to write 2L all the time, as the length is L only. So, we will take the length of this dipole to be L. So, Q into L. Initially, there was the gap between the 2 charges 2L, that's why we took 2L. This time it is L, we will take L. So, Q into L, that is the dipole moment of each. And my dear students, do you remember I told you that 2 vectors of equal magnitude making an angle 60 degree will have a resultant root 3 times of any one. So, that is the answer, root 3 QL. Now,